Hello, aspiring Java developers. Welcome back to the channel. Today, we are diving deep into one of the most powerful and sometimes challenging aspects of Java programming, multithreading and concurrency. This topic is crucial for building high-performance, responsive, and scalable applications. By the end of this 5-minute tutorial, you will have a solid understanding of how to manage multiple tasks simultaneously, avoid common pitfalls, and write efficient concurrent Java code. We will cover creating threads, ensuring data integrity with synchronization, understanding inter-thread communication, and exploring best practices. So, grab your virtual pen and paper, and let us get started on this exciting journey to master Java concurrency. Alright, let us kick things off by understanding the very foundation, how to create and manage threads in Java. A thread is essentially a lightweight subprocess, the smallest unit of processing that can be scheduled by an operating system. Java provides two primary ways to create threads. First, you can extend the thread class and override its run method. Second, and generally preferred for flexibility, you can implement the runnable interface and pass an instance of your runnable implementation to a thread constructor. The run method contains the code that will be executed by the new thread. Remember, calling start on a thread object actually creates and starts the new thread, while directly calling run just executes the code on the current thread. Implementing runnable promotes better object-oriented design as it allows your class to extend another class while still defining thread behavior. Now, when multiple threads access and modify shared resources simultaneously, we often encounter a problem called a race condition. This can lead to unpredictable and incorrect results. To prevent race conditions and ensure data integrity, Java provides the synchronized keyword. When you mark a method or a block of code as synchronized, only one thread can execute that code at any given time for a particular object. It uses an intrinsic lock, also known as a monitor lock. When a thread enters a synchronized method or block, it acquires the lock. When it exits, it releases the lock. This mechanism ensures that critical sections of code, where shared data is accessed, are executed atomically, meaning as a single, indivisible operation. This is fundamental for building reliable concurrent applications. Let us put our knowledge to the test with a classic concurrency problem, the producer-consumer problem. Imagine a shared buffer where a producer thread adds items and a consumer thread removes them. We need to ensure that the producer does not add items to a full buffer and the consumer does not try to remove items from an empty buffer. For this, we use inter-thread communication methods, wait, notify, and notify all. When the buffer is full, the producer calls wait to pause itself, releasing the lock. When the consumer takes an item, it calls notify or notify all to wake up waiting producers. Similarly, if the buffer is empty, the consumer waits. This elegant solution, always used within a synchronized block, allows threads to cooperate efficiently without busy waiting, conserving CPU cycles and preventing deadlocks. While multithreading offers great power, it also comes with potential pitfalls. One of the most notorious is deadlock, where two or more threads are blocked indefinitely, waiting for each other to release resources. Another is live lock, where threads continuously react to each other without making progress, or starvation, where a thread repeatedly loses the race for a resource. To avoid these issues, always strive for minimal synchronization. Also, leverage the java.util.concurrent package, which provides high-level abstractions like executor service for managing thread pools, countdown latch, cyclic barrier, and thread-safe collections like concurrent hashmap. These utilities simplify concurrent programming significantly and reduce the chances of introducing complex bugs. Prefer immutable objects for shared data whenever possible, as they inherently do not require synchronization. And there you have it. We have covered the essentials of Java multithreading and concurrency. We started with creating threads using the thread class and runnable interface, then moved to ensuring data integrity with the synchronized keyword. We explored inter-thread communication with wait and notify all in the producer-consumer problem, and finally, discussed common pitfalls like deadlocks and best practices using the java.util.concurrent package. Remember, practice is key. Try implementing these concepts in your own projects. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe for more advanced Java programming tutorials. Keep coding, keep learning, and I will see you in the next video.